Let's think about the units that we use to measure area. We use millimeters squared, centimeters squared, meters squared, or we can say square millimeters, square centimeters, square meters, and so on and so on. Now we know that the squared part means we're measuring two dimensions, in this case, length times width. And for volume, we use cubic units, cubic centimeters or centimeters cubed, and the same with cubic millimeters, cubic meters, and so on and so on. And in this case, we're measuring in three dimensions, and that's what the cube part means, length times width times height. Now, imagine that we're measuring a perfect square or cube each time. So the length and width of our square are exactly the same. Let's say 2 centimeters. To find the area, we multiply 2 times 2. And we find that our area is 4 square centimeters or 4 centimeters squared. If we take it to the third dimension, we have a cube with length, width, and height all measuring 2 centimeters. To calculate the volume, we multiply 2 times 2 times 2, which gives us 8 cubic centimeters. When we talked about multiplication facts, we also learned that any number times itself is called a square number, and we can see that really clearly as a cool diagonal line on a multiplication chart. So, because 2 times 2 equals 4, 4 is a square number. So is 9. So is 16. So is 25 and 36 and 49 and 64 and 81 and so on and so on and so on. Now, the same is true for cube numbers. So 2 times 2 times 2 equals 8. That means 8 is a cube number. And 3 times 3 times 3 equals 27. So 27 is a cube number. And so on and so on and so on ad infinitum, which means to infinity. Now, one way we can write squared numbers is like this: 2 squared. That small little number up on the top right-hand corner tells us that the number is 2 times itself. And we can write cube numbers in a similar way. So what number do you think we'll put in the top right-hand corner if we want to write 2 times 2 times 2 this way? That's right, 2 cubed, or 2 with a tiny little 3 up in the upper right-hand corner. Now, what if I wanted to figure out 2 times 2 times 2 times 2? Well, I would write it like this. And how about 2 times 2 times 2 times 2 times 2? That's 5 times. I would write it like this. And those tiny little numbers in the upper right-hand corner that tell you how many times to multiply a number by itself, they're called exponents. And they just mean, well, we multiply the number by itself, the number of times shown by the tiny little number. So when we say it out loud, we can say 2 times 2 is 2 squared. 2 times 2 times 2, or 2 times itself 3 times, is 2 cubed. But when we get any bigger than that, we say to the power of, or to the nth power. So 2 times 2 times 2 times 2, or 2 times itself 4 times, is 2 to the power of 4, or 2 to the fourth power. And our last equation on the screen, 2 times 2 times 2 times 2 times 2, 2 times itself 5 times, is 2 to the fifth power, or 2 to the power of 5. So what do you think this number would be? 10 cubed. What if we wrote it out without exponents or as a multiplication equation or anything? Just the number itself, all simplified. Did you say 1,000? If so, big old pat on the back. You see, the way we figured it out is that we know 10 cubed means 10 times itself 3 times, or 10 times 10 times 10, which gives us 1,000. When we start dealing with really big numbers, they take up a lot of space on our page. And this is a good example. 10 times itself 7 times. Well, if we evaluate or simplify this expression, we get 10 million. And that still takes up a lot of space on the page, but it's only 10 million. And Yeah, I know that's a really big number, but we've been studying the solar system and we know that there are things that are way farther apart in space. The distances are so vast, the numbers are so big. It's way bigger than 10 million, it's hundreds of millions, it's way beyond that, even. So, how do we think about these numbers? How do we write them out? Imagine writing all those zeros out on a piece of paper. You'd never have a piece of paper long enough. You'd have to go on to the next line, and that gets really confusing. So, this is where exponents come in super handy. This number 10 million can be written as 10 to the power of 7 or 10 to the seventh power. So 10 times itself 7 times 10 million or 10 to the seventh power. One of them's really small and really efficient. And in math, we're always looking for efficient and accurate ways of doing things that are more simplified. One of the beautiful things about working with tens and exponents is a little trick. The exponent tells you how many zeros come after the one. So if we have 10 to the power of 7, there are 7 zeros after the 1. And if we had 10 to the 27th power, that would mean there were 27 zeros after the 1. So you can see how using exponents instead of writing things out the long way can save a lot of time and space. And in math, since we are always looking for efficiencies and simplicity, that's why exponents are a great thing to understand.